Who says? Who says? Oh, these aren't my glasses. Who says I didn't?
Yeah, maybe you shot it after the picture.
Yeah, I took the picture of it and then put it in my freezer. Okay.
Why would she shoot it first and then take a picture?
People do that.
Oh,
Okay.
cute.
9.4.
I know.
Graphing, linear functions. Okay, again, just like I was saying just a while ago, linear, if you notice, has the word line in there. So we're graphing lines. That's what we're doing. Say function whose graph is a line. It contains not more than two variables. What are variables again?
Letters.
Letters.
Constants.
That's right, constants are letters. Are numbers, yes. So it contains not more than two variables, which are letters, expressed only to the first power. You know what that means? Only expressed to the first.
Is that like
It
to the power of 3?
What?
It doesn't have any exponents?
Has no exponents. Just one. The number one. So yes, first power, meaning you're not going to see squared or cubed or to the fifth power or something. It's it's written with two variables. Guess which two variables it always is, pretty much.
X. AV? What was the question?
X and Y.
Oh.
X and Y.
I knew that.
When we're graphing linear functions, you're thinking of the functions that we talked about last week. F of X, G, yeah, exactly. So you know what you're talking about. But this one, just see if y'all could guess. This time we're going to be dealing primarily with that Y and the X.
Is that a 1?
But because we're talking about functions, you're going to probably see an F of X.
That's the next question.
For example, this is primarily what they look like, how they're written. But of course, we're talking about functions, so this is what they are typically looking like. What did I teach y'all last week? This F of X really is representing what?
Y.
Bingo. Notice that both have the same equation. So far, I'm just introducing this stuff to you. We're going to start really jumping in just a second. I have just 2 pages of notes. Now, for Algebra 1 class, since some of y'all still writing, I start this chapter they're in. Every year I've taught Algebra 1, they've only had about a page or 2 of notes. This year's Algebra 1 class, it's taking about 6 pages for them to barely get it. I don't know what's going on. I think they're tired. They need spring break. Okay.
That's still a month away.
I know. That's going to be a long month. If an ordered pair, remember what an ordered pair is, an x and a y, makes the equation true when the x and y values are substituted it's considered a solution, which is a fancy word for answer. So that's how we're going to check what the answer is. We're going to be substituting. If an ordered pair, an x and a y, makes the equation true, remember this is the equation we're talking about, when the x and y values are substituted, it's considered a solution, meaning it's a true answer. And I'm going to give you an example on that. Taylor, how you doing way back there? If you need to move up, you can move up, okay? All right. Okay. So, I'm going to take this equation and I'm moving it down here so I can show you my example. Here's my equation, y equals 2x plus 3. And the question is -1 and 2 a solution? So here's my equation. They gave me an ordered pair and they want to know, is that a solution to the equation? Is that a true statement, basically? So, what is my -1?
Your x.
That's right. So what is my 2? All right. And what we're going to do is we're going to substitute. We're going to substitute that -1 into that x. And we're going to substitute that y into that y. We're subbing that. So I'm going to rewrite this equation with these in place of my x and my y. So this y will be 2. Do y'all see where I'm getting that?
Mm-hmm.
If you don't, you need to say something. So I'll substitute that y for that y right there in the ordered pair equals 2. Now, what operation is taking place with the x?
Multiplication.
Multiplication. So we're going to substitute that -1 in place there. So it's going to be 2 times -1 plus 3. So what is 2 times -1? -2, right? Plus 3. What is -2 plus 3, Emily? Do what? -2? Regular 1. So, does 2 equal 1, Emily? No. 2 does not equal 1. So, therefore, this is not a solution. So see what you're doing? You're just substituting to see if that ordered pair that they gave you is a solution. It's going to be yes or no type answers. Yes, it is, or no, it's not. If we substituted and worked it out and it was 2 equals 2, then that would be a solution. Yes.
The answer has to equal to y? Or does it have to equal to y?
This side, yes, the answer has to equal to y. If it was 2 equals 2, then yes, a solution. But if it doesn't equal it, then it is not a solution. Does that make sense? Any questions about that? That's not too bad, right? The only problem you're going to have is when they ask you, is that a solution? You may be like, I don't even remember what they mean by that. What do they mean by as a solution? And so that's why we do these examples, because sometimes it's hard to decipher what they really are asking. Okay. Next, we're going to be finding ordered pairs that satisfy a linear function. And here's how you do it. First, you're going to find at least 3 ordered pairs for accuracy in determining the line. And I'll explain that to you as well. Whoops. Determining. I misspelled that. Determining. Wonder how many of y'all would have caught that. Okay. So first you're going to find at least 3 ordered pairs for accuracy in determining a line. Okay? When I say accuracy, because guys, when we're graphing a line, if you just do 2 dots, the Algebra 1 class will tell you that it's not always going to give you a complete line. When you start getting your rulers out and everything and trying to line those dots up, it could give you skewed answers, like not complete answers. So you want to have at least 3 dots before you draw your line and connect your dots to make sure that it's completely accurate. Okay, next. Choose any 3 real numbers, not fake ones. Emily liked my jokes. To represent x in an equation.
Is there a fake number?
Of course. Then solve for y. Okay, choose any 3 real numbers. Just, regular numbers to represent x in an equation, and then you solve for y. Now, I will tell you, even though your book doesn't tell you this, you should choose at least 1 negative and 1 positive to get a complete line. You should. You should also choose ones that work. And I'll explain that to you later as well. I don't know how much that's detrimental in pre-algebra, but in Algebra 1, they have equations that have like fractions in there that say 1/3, and they'll choose all the wrong numbers, and it makes their life just miserable. And if you look ahead, you can choose appropriate numbers. But anyway, y'all don't have to really worry about this right now. I'm looking at the examples. No, y'all are not there yet. Thank goodness.
Are we at halves yet?
Halves? What does that mean? What do you mean? Are we at halves
I
yet?
said they have 1/3.
Oh, yeah, y'all are going to be, let's see. Y'all may be doing fractions, yes. But it's not going to be anything scary like in Algebra 1. All right. So, example. This is given. This is like a problem in your book or something. If they said f of x equals x minus 4, and they tell you to graph it. That's all they give you. That's it. And you have to graph it. Well, guys, let me show you how you do that. By the way, what is f of x? What did I tell you that kind of means?
Why?
Very good. Only one person answering. This is basically your y.
Can we just write y?
There you go.
Can we just write
Now
y?
you need to, if you are going to write that, you need to write it below it so that you know the difference, okay? Okay, so this is your equation. We need to graph it. The only way to graph it is by finding a bunch of ordered pairs that we can connect the dots, kind of like y'all's picture. So we're going to set up a table. And I'm going to put, and like Taylor said, can we just put y? Well, sure, let's put just y. And over here is going to be your f of x or your y, whichever. But we're looking for ordered pairs. Okay, so this is your equation. Now, y'all, did they give us any x's to substitute in there? Did they, guys? Cecilia, did they give us any x's to substitute in here to find the y? Nope, all they gave us was this equation and said find it yourself. So let's choose 3 random x's. I can choose, let's do -1, 0, and +1. Now remember, you choose 3 random numbers. Those are off the top of my head. You could have chosen -2, 0, and +2. You can choose any 3 random, but I suggest 1 negative, 1 positive.
But they should be like the same number.
I mean, it's up to you. It just makes it easier. And I always choose 0 because sometimes it makes it easier. So now we're going to substitute those x's into this x. Do y'all all see that? Okay, so I'm going to do y equals -1 minus 4. Do y'all see what I'm doing? So then what would that be, Joanne?
It'd be
-5. So then my ordered pair here, what's my x, Joanne?
Your x is -1.
And then my y is? What did we say our y is? What? Okay, because so see, we solved y equals -5. Do y'all see that? Do y'all see that? All right, Cecilia. I'm going to substitute the x for this x. So if the x is 0, what is my y?
4. -4.
Very good. So then what's my ordered pair? Cecilia?
0, -4.
Perfect. Any questions yet? Michael, I'm substituting my x for this x I chose. What would my y be?
Negative 3.
So then what's my ordered pair?
1 and negative 3.
Perfect. Okay, so now that I have my ordered pairs, I can draw my Cartesian plane, and you are going to be using your rulers and straight edges for this. And I'm going to plot these three numbers. And hopefully you've been doing your IXL so you know where to plot these. So that would be -1 and then -5. 1, 2, 3, 4, 5. Y'all have graph paper, so it'll be a little bit easier. 0 and -4. 0 and 1, 2, 3, 4. And then 1 and 3. 1 and -3. And then with a ruler, we would connect the dots. Now my lines aren't very straight. And that's how you graph a linear function.
That's simple enough.
Huh?
That's simple.
It's very simple. So make sure you have this. It's simple for some people. You'd be surprised at how many people actually struggle with this.
I have a question.
Yes, sir.
What if we chose the same 3 numbers every time?
You can. My go-to numbers, especially in Algebra 1, are -2, 0, and 2. But if it has a 1/3, like 1/3 times x, I'll choose, because it has a 3, I'll choose, instead of 2, I'll choose -3, 0, and +3. Because I'm dealing with a third, you know what I'm saying? If I had a fraction in there that's being multiplied by the x, and let's say the fraction was 1/5. Well, if I choose a 3 or a 2, that's going to give me some really weird fractions. But if you chose like -5 and 5, it works better. That's what in Algebra 1 you got to look ahead and choose appropriate numbers. Does everyone have this? Are there any questions? All right. So open up your book to page 366 for examples.
That's 2/4, 366.
366.
Have we gotten very far in the book?
Yes. We're right on schedule.
We're past that point. Yeah.
Okay. Number 2. I'm looking around, make sure everyone's got their books open. Okay, Izzy, read the directions.
Is the negative ordered pair of solutions to the equation y equals 2x minus 9?
Okay, so there's your equation. You could like maybe circle it, underline it, star it, because you're going to be using that equation in all of those numbers there. So the equation is y equals 2x minus 9. And they want to know if the ordered pair for each of those numbers is a solution, an answer to that equation. So for number 2, the ordered pair is 8 and -2. So if this is my x and this is my y, I'm going to, remember, we're going to substitute the x and the y and then solve to see if they equal each other. So Izzy, tell me how to solve this. What would my new equation look like?
2 equals
What?
-2 equals 2 times 8 minus 9.
Very good. And Izzy, what is 2 times 8?
16.
And what is 16 minus 9? So does negative 2 equal 7? No. So then your answer is no. It is not a solution. Any questions about that? Everyone have it down?
No, 1 second. Just write 18 instead of 8.
All right, number 4. Using the same equation, this time we have the ordered pair a half and negative 8. Emily, what am I going to do? All right, what am I substituting?
-8 is the y.
Very good. Negative 8 is your y, and
The half goes to the 2.
half goes just to the x. Yes, very good. Perfect. Okay, so once you have that written down, what is my new equation, Emily?
-8 equals 2 times half minus 9.
Perfect. Do you know what 2 times a half is? We'll look over here. So 2 over 1 times 1 over 2. What do you get? Multiply across.
2 over 2.
And what's 2 over 2 equal?
1.
So then 2 times a half is
1.
perfect. 1 minus 9. Basically, you could say, what's half of 2? Well, 1. Okay, so what's 1 minus 9? Perfect. So does negative 8 equal negative 8? It checks. So then your answer is yes. It is a solution. Good job. Any questions so far? All right, look at number 8. Michaela. Same. No, wait, no, that's different. Michaela, read the directions.
Is the given ordered pair a solution to the equation y equals negative x plus 8?
Okay, so we have, you can circle that, highlight it, put a star, but that equation is what you're using for those problems. Y equals negative x plus 8. And number 8, the ordered pair, and we're doing the same thing, is 14 and negative 6. So you're basically doing the same thing. Okay, so, Michaela, how do I solve this?
Replace negative x with negative 14.
You're putting the 14 in place of the x. Yep.
And the negative 6 for the y.
That's right. Okay, so what would my new equation look like?
Negative 6 equals negative 14 plus 8.
And I would encourage you to put your 14 in parentheses, because if that was a negative 14, you'd have to put that negative in there. But since it's not, we're just going to put it like that. So yes, that is a negative 14. So what's negative 14 plus 8?
Mm. -6.
Very good. And does that work?
Yes.
So your answer is yes. Any questions? I have 2 more. Once you have this down. Maybe 3 more. Everyone have that down? All right. Look at number 10. Same one, y equals negative x plus 8. And the ordered pairs negative 4 and negative 4. Gabby, tell me what to do. Very good. So what does my new equation look like? Very good. Okay, notice that we kept this in parentheses. So now we have a negative negative. So Gabby, what does negative in front of a negative mean? So we're going to rewrite that as plus 4 plus 8. That's a positive 4. You don't even have to put that plus there. It's just, positive. So Gabby, what is 4 plus 8? So is that a solution? Perfect. Good job. Okay. Any questions? Look at 14. It says for each equation, make a table of ordered pair solutions for. And they told us in the directions, x equals negative 2, negative 1, 0, 1, and 2. All they're asking for now is they're looking for ordered pairs. At no time did they say graph it. So it says make a table. And 14, your equation is y equals negative 2x plus 7. So let's make a table. And they didn't tell us we had to graph it, so that's good, but the next section you will. Okay, so let's see. Taylor, what do I put in the x column?
Put -2, -1, 0, 1, and 2.
Very good. And we're just going to start substituting the x's. So I have y equals negative 2 times negative 2 plus 7. So Taylor, what is negative 2 times negative 2 plus 7?
11.
So what's my ordered pair?
-2, comma, 11.
Perfect. So we got our first one. Any questions? Wit. Y equals negative 2 times negative 1 plus 7. What's negative 2 times negative 1?
Positive 2.
Plus 7?
9.
So what's my ordered pair?
Negative 1, comma 2. Or 9.
Very good. Aiden. I have y equals negative 2 times 0 plus 7. What's negative 2 times 0?
0,
Plus 7.
7.
What's my ordered pair?
Do 0, comma, negative, plus 7.
Very good. 0, 7. Cecilia, I have y equals negative 2 times 1 plus 7. What is negative 2 times 1?
-2.
Plus 7.
-9.
Negative 2 plus 7. Negative and a positive.
-5.
If the signs are different, do you add or subtract?
Subtract.
And take the sign of the
Larger number 5.
5. So what's my ordered pair?
1, 5.
Very good. And the last one, y equals negative 2 times 2 plus 7. Izzy, what's your ordered pair? And those are your answers. Any questions? Now in the next group, down below, see exercises B, 17 through 32. You are to choose your own x's. Now look at number 23. Real quick. That's the one I was talking about. I was wrong. Y'all would have it. Do you see that it's y equals x over 6? Y'all see that? If you were to choose a 2, that would be 1/3, right? Wouldn't that be hard to graph? So what number should you choose as random x's for something like this?
6.
3. 3.
6 would be really good. 6 divided by 6 is what? 1.
-6 divided by 6 is 1.
That's right. Choose multiples of 6. Like 6 or -6 for that. Huh? No? That would be 2 and 3 for 6. Multiples would be 6, 12, etc. Do you not remember multiples? Okay. All right, page 366. You're going to do numbers 1 through 25. Yeah. Odd.
Still doing 23.
Yep. That's 13 problems. The part B, 17 through 25, you must graph. Y'all see that? You must graph for 17 through 25. This is due Tuesday. You have a quiz Wednesday. When did I say IXL's due?
Wednesday.
Okay. And your test will be on the 6 weeks exam, which is a week from Friday. Okay, get started.